Welcome everyone to this video. So we are going to discuss and review some questions which have come in recently concluded JEE mains examination. Uh, so this is the paper which was held on 28th of January, evening shift. So we are uh, going to discuss question number one here, question number three, and one more question within the text. So let's begin. Basically, the first question is that of semiconductors. So we have to identify the logic gate, which is provided here in form of two uh, NOT gates. So if I have focus here a little bit so that it is clearly visible, we have two NOT gates here, and these two NOT gates uh, they are reverse biased, because if we have the option that some current is supplied from point A to the point Y, then reverse bias would be the one condition in which this diode will operate. In the same way, the diode from B to Y will also be in reverse bias condition. But here we are also provided some additional voltage 5 volt, uh, which is connected to the output of the points A and B, that is of the diodes, this and this. So what happens is that when current is passed from this 5 volt potential to point A and point B, and under various conditions, uh, either the current will flow to Y, or the current will flow to A or B. So what happens is that if A and B, let's say both of them are in off state. So when they are on off state, that means A and B both are in low voltage state. So low voltage state indicates that the current going from 5 volt to A would actually make the conductor diode A in forward bias. Uh, in the same way, so that means that the condition which we were earlier stating, that if the current would flow from A to Y, it would be in a reverse bias condition. That would have been the case had there been no presence of this 5 volt potential. But since this 5 volt potential is there, that means that A will actually get forward biased. So in the same way, if B is also having lower voltage than 5 volts, it will also get forward biased. So because of this, if A and B both are supplying no signal to the whole logic gate, then simply the 5 volt will provide the current to A, make it forward bias, and provide current to B, make it also forward bias. So all the current from 5 volt will flow to A to B, and none of the current will flow to the point Y. So that is basically the point of whole logic gates, or logic gates, which basically we have to draw operation from such a circuit, that whether the current is going to flow from the external potential to the output of the circuit. If the current is flowing, that means that it is 1. If the current is not flowing, or some less current is flowing, that means it is 0 in off state. So when A and B both are in off state, that means no current is flowing to Y. Next. Uh, Again, now, if A and B, if A is in on state, that means that would oppose the voltage which is providing this current. So that means that in that case, A will be in reverse bias case, so no current would be flowing like that. So next, again, some current is flowing like this 5 volt current is flowing from point 5 volts to point B. So when this current is flowing, the voltage would automatically uh, make the point B in forward bias because B is in off state. So even if A is in on state, B being an off state makes that the whole current which is provided by 5 volt goes to point B. So I'll basically just repeat this whole case which I have described, that when A is in on state, that is A is 1 and B is 0. In that case, A is in reverse bias because it is also high voltage. So current is unable to flow here. But since B is 0, B is off, the current can flow from this point to this point. So when A is 1, B is 0, current is still unable to go to Y. The reverse case would be when A is 0 and B is 1. Again, the current would be unable to flow to Y. But when A and B both are 1, then A and B both are in reverse bias. So current would be unable to flow to point A and point B. Current would completely go to point Y, which is the point that it would be an AND gate. Next. So here we are concerned with a prism. So prisms of late have been catching a lot of attention with JEE uh, exams. Like in the exam which was just concluded in 2023, so it's recent by matlab, the standards of ITJ. They had a nice question on on prism, that if there is a plane polarized light which is incident on a prism, then what happens? In the same way, we have a question here that the prism is operating in the condition of minimum deviation. So we are given that the uh, minimum deviation produced by a prism is equal to the refracting angle of prism. That is, the deviation delta is equal to angle A. So that is what is given to us. And not only it is deviation, it is also minimum deviation. So we have to choose that what is the range of refractive index of the prism from this information. So this is like a question in which first we have to look focus on what we know. So we know that refractive index of the prism mu is related to these two quantities using the relation sine A plus delta by 2 upon sine A by 2. So this is one of the relations which we know in case of minimum deviation. So when delta is equal to A, then what will happen? Then we will say that okay, this is sine A upon sine A by 2. So when this happens, we can divide sine A to 2 sine A by 2 cos A by 2. And we can divide this by sine A by 2. So when we cancel this out, this whole term becomes equal to mu. So mu is 2 cos A by 2. So this implies that if you have a refractive index of the medium which is mu and it is equal to this value. So if you want to find what is the maximum value of mu, right? So we would have to find what are the variations in the value of A, right? So the variations in value of A can be anything. Angular prism is not known to us, right? Maybe the uh, you know some other people may know, but we know that deviation is equal to angle of prism. So using this we can say that what can be the maximum possible deviation? The maximum possible deviation can be pi by 2. So when maximum possible deviation is pi by 2, so a can at max go to pi by 2. So that means mu can go up till 2 cos pi by 4. So this is square root 2. This is the refractive index of the medium which we wanted to evaluate. So this is the one of the values of mu, right, which we can find, right? So that's it. Thank you for joining.